Welcome to Lesson B-5. In this lesson, you will learn more about working with different types of switches, including a slide switch, to accomplish various tasks. And then in the next video, you'll also learn to write code to overcome an electrical shortcoming of switches known as switch bounce. In this video, we will revisit the concept from Level A of pulling GPIO inputs up or down as a default, so user inputs such as a switch being pushed can be registered by the program. We'll then talk about a new component, a slide switch, which you will have a chance to work with in the activities for this lesson. Okay, let's dive in. Back in Level A, you learned how to use pull up and pull down resistors to keep inputs reading high or low by default. As you see here in this diagram, in the final project for Level A, we pulled down two inputs using 10,000 ohm resistors. This hardware configuration allowed the program to register when a user pressed a push button switch on the circuit. Now, during that same lesson, we also discussed how pulling a GPIO pin up or down was important, as otherwise inputs are left to float. A floating input will unreliably measure as high or low. So while it's useful to understand the basics behind using resistors for pulling up and pulling down GPIO inputs, which is an electrical configuration using hardware, let's dive in and talk about the software option for accomplishing the same task. Now, the Raspberry Pi can help you simplify circuit design by doing the pull up and pull down work for you. The Raspberry Pi contains internal resistors that can be accessed when setting up a GPIO pin as an input, and this will simplify your switch wiring as you won't need the high value resistor. Instead, a single jumper wire will run from the GPIO pin to the switch, and another wire from the switch to 3.3 volt or ground, depending on whether you want a high or low to trigger the input. In Python, pulling an input up or down can be done when the pin is assigned as an input by supplying a third parameter called pull up down, as you see here. Now, this command will initialize GPIO 12 as an input and configure that input to be internally pulled up. This input will be an active low, which means this input will remain high until it's made active by connecting it to ground or low, hence the name active low. GPIO 12 will now only need to be connected to ground to trigger the input, which can be done very simply using a switch and two wires. The opposite of active low is active high, which means the input will remain grounded or low until it is made active by connecting it to 3.3 volts. This can be accomplished by using GPIO.PUD_down after the pull up down parameter seen here. Okay. Now this command will initialize GPIO 20 as an input and configure that input to be internally pulled down. GPIO 20 will now only need to be connected to a 3.3 volt to trigger the input, which can be done with a switch and two wires. Okay, so as you can see, this is a much simpler setup than when we were using, high value resistors to physically pull down these pins. Now with the software, it's just a couple of codes and we've accomplished the same thing. Okay, so until now, you've only worked with the push button switches, right, from Level A that make connection when they're pressed, but they lose that connection when they're released. There may come a time when you want a switch to stay connected without being pressed. This type of switch is called a slide switch or a toggle switch, and you'll get to work with one in the activities for this lesson. A toggle switch toggles one or more inputs between one or more outputs. One very common type of toggle switch is this two-position slide switch like you have in your kit. In a two-position slide switch, the center pole can connect to one of the throws at a time based on the position of the slider. These switches can be used as power on, power off switches for electronic devices by connecting power through the center pole as well as one of the throws. A slide switch can also be used as a selector between two different inputs. So like in this diagram here, a slide switch is connected to two GPIO pins with the center terminal attached to ground. In one position, GPIO 5 is grounded and GPIO 6 will be internally pulled up by the Raspberry Pi. In the other position, GPIO 6 will be grounded and GPIO 5 will be internally pulled up by the Raspberry Pi. Programming for a slide switch is identical to the programming you've already done for push button switches. Your program could use these switch inputs to light up different LEDs, modify the frequency of a piezo buzzer, or anything else you might want to control. Okay, before you move on to the next video, let's just take a few moments and review the concepts we just discussed. First, we reviewed how hardware can be used to pull GPIO pins up into a default high state or down into a default low state using high-value resistors like we did toward the end of level A. But we also talked through the basics of how GPIO pins can be pulled up or down via Python code. It's a little bit easier. We then talked about how slide or toggle switches work, including briefly reviewing their internal configuration and how they can toggle between power on and off, and how they can toggle between GPIO pins. You'll get a chance to work hands-on with the slide switch in the activities for this lesson. Okay, now that you know more about pulling GPIO pins up and down, as well as working with a slide switch, go ahead and move on to the next video for this lesson, where we'll talk about how to overcome switch bounce.